Section 1.2, we're looking at graphs of equations. It's important to remember we're looking at equations, not functions. Functions need to pass that vertical line test. So whenever you draw a vertical line through the curve, it should only be hitting the curve at one spot. Equations, that's not a requirement. Vertical line can hit an equation more than once. So even though that vertical line is hitting that curve more than once, that's okay. That fits the definition for equations. So I just want to say that before we start, we're working with equations, okay? So we're going to look at some basic properties here. Solutions of equations, an ordered pair that makes the equation true. So when substituted in, you get a true statement, the same value on both sides. So just doing a little bit of a check. We have our equation right here, y squared equals 8x plus 4. So we have 3 points we want to test out. We're simply plugging in, seeing what we get. So we have our ordered pair, 1.5 comma 4. Those are our x and y values. So take our 4, plug it in for that y value. So 4 squared. And take your 1.5, plug that in for your x. From here, just using your handy-dandy arithmetic skills, seeing what you get. 4 squared is 16. 8 times 1.5, that's going to be a half of 8. 4 added on, 12. So 12 plus 4, 16. That checks out. Okay, so this is a solution to that equation. If you were to graph this entire equation, this sideways facing parabola, the point 1.5 comma 4 would be on that curve. So for these 2 points here, you would just test those as well. Plug them into the original equation, y squared equals 8x plus 4, and see what you get. Now some solutions to equations will fall on an x or a y axis. These are called intercepts. There's a lot of different ways that this can look. You can have a graph that has one intercept, you can have a graph that has two intercepts, you can have a graph of an equation that has no intercepts. Okay, so you want one intercept, maybe your equation is a line. You want two intercepts, maybe your equation is a parabola. You want 0 intercepts, maybe your equation is a circle. So there's a lot of ways that that could happen. There's a lot of different ways equations can look, which means there's a lot of different ways you can get these specific solutions called intercepts. X and Y intercepts. The reason we're focusing on intercepts is that's really what we're moving into next, okay? There's a very important thing about an intercept, is that an intercept, depending on the axis you're on, has 0 for either its X or its Y value. So that's a known amount. So if you want to find an x-intercept, any point that's on the x-axis, okay, let's get a little coordinate system here. Any point on the x-axis, we know that any point on that x-axis has 0 for a y value. That's just how it works, okay, because you haven't gone up or down. Over here, negative x, comma 0, anywhere on that x-axis. On your y-axis, okay, any point on that y-axis is going to have 0 for the x value because you haven't moved to the right or to the left. All right, down here, 0 comma negative y. So to find an intercept, you want to use that powerful information that the other value is going to be 0. So to find x and y intercepts, let's start with example A, okay? Y equals x squared minus 2. Find the x and y intercepts of that. So let's kind of split this up into 2 problems, okay? We're going to have our x-intercept part of the problem. We're going to have our y-intercept part of the problem. So to find an x-intercept, we want a point that is on the x-axis. That means that your y value is going to be 0. So take your equation, plug 0 in for y. Once you've done that, this is an algebra problem. We're solving for x. Add that 2 over x squared, square root. Now here's the thing. These are equations. There can be more than one answer. So when we take that square root, we want the positive and negative values. We're looking for both of those. For our y-intercept, we want a point on the y-axis. Any x value is going to be 0. We're going to use that information to say, okay, this x right here, if we want to know the y-intercept, that means that x value is going to be 0. You simplify down, and you have your y-intercept. So, looking at ordered pairs that are solutions to equations, plugging them in, realizing that solutions can fall on an axis, we call those intercepts. Finding intercepts, utilize this information here. Depending on the axis you're on, one of your values is going to be 0. Do some substitution to solve for those.